Hi, Matthias from 10-Minute Physics here. Welcome to tutorial number 8. Today I will show you how to let the user interact with a 3D scene. It took me quite a while to figure out how to map between the different coordinate systems of the browser, how to properly switch between camera control and dragging, and how to use the Raycast feature of 3.js properly. I put all this knowledge into one clean and simple class called Grabber. We will use it in future tutorials and you can use it for your demos as well. Let's start. We have a 3D scene. What we see on the screen, however, is a projection of this world. The projection depends on the position and the orientation of the camera. Let's assume we click at the two-dimensional position P in screen coordinates. Where is this point in our 3D world? The answer is not unique. The point can be anywhere on a ray that is defined by an origin and a direction. This ray is called the mouse ray. The camera sees this entire ray as a single point. You can reproduce this scenario. Take a pencil and open only one eye. Now you can orient the pencil in such a way that it appears as a small single disc. The next concept we need is raycasting. Let's assume we have two spheres in our scene and the user clicks at the red location. From this, we can compute the mouse ray with its origin and its direction. Casting a ray means computing the intersections of the ray with all the objects in the scene. A single object can potentially be intersected multiple times. A raycast operation typically returns only one hit per object, the one that is closest to the ray's origin. Since the ray can intersect multiple objects, the raycast function returns a list of pairs of distances and object references. In 3.js, this list is sorted by distances. It is also possible to associate a layer number with each object. If a layer number is passed to the raycast function, it only returns objects with that layer. From the distances we can easily compute the 3D positions of the intersections as the origin of the ray plus its direction times the distance to the intersection. We can now use raycasts for enabling the user to drag objects. When a mouse event occurs, we compute the mouse ray. Next we use raycasting to find the closest intersection of the mouse ray and the scene. We then compute the intersection point P down and notify the object returned by the raycast function with a drag start event passing P down. We also store the distance D down. When a mouse move event occurs, we first compute the new mouse ray. To compute the new drag position, we don't need to call raycast. This time we use the stored initial distance from the mouse down event. We now notify the object with a drag move event passing the new drag position. When a mouse up event occurs, we simply notify the object with a drag end event. Each object will handle the events drag start, drag move, and drag end differently. Here is a simple version for rigid bodies. This is also the one we will implement in this tutorial. We simply ignore the start event. When a move event occurs, we simply move the body to the new drag position. Here is a more advanced version. At the start event, we compute a local attachment position on the body by transforming the drag position into the body's local frame. We then create a zero-length spring between the attachment point and the global attachment point. At the move event, we set the global attachment position of the spring to the new drag position. This way, the user gets a feel of the weight of the body as well. Here's a way to implement dragging for soft bodies. At the start drag event, we find the particle closest to the drag position and make this particle kinematic. At the move event, we set the particle's position to the drag position. At the end event, we make the particle dynamic again. So now let's code this. Okay, so this is the goal of the tutorial. I took the scene from tutorial number 2 with the red sphere in the 3D scene, but now the user can pick it, move it around, and throw it. As I just mentioned, we used a 3D demo with the red sphere from tutorial number 2 to demonstrate user interaction. Therefore, I will only focus on the code that we have to add to this example to enable user interaction. The core of the implementation is an object I call Grabber. It handles mouse down, move and up events and calls the grab start, move and end methods of the grabbed physics object with the grab position and velocity. First, we add 4 lines at the bottom of the function ini3scene. The first one creates a new grabber object. The next 3 lines make sure that our onPointer function is called when pointer down, move, or up events occur. A pointer event represents both a mouse or touch event. The onPointer function is quite simple. It basically feeds the grabber object with the necessary information. When a pointer down event occurs, we call the start method of the grabber with the x and y coordinates of the mouse. Also, if the grabber picks up a physics object, we turn camera control off. If a pointer move event occurs, we call the move method of the grabber, again providing the x and y coordinates of the mouse. If we get a pointer up event, we call the grabber's end method and turn camera control back on. Here's the definition of the grabber object. In the constructor, we create a Raycaster object provided by the 3 library. We also store the grabbed physics object, the distance, the previous position, the velocity, and the simulation time. The time is used to compute a grab velocity. The increase time method is called by the simulation function and enables the grabber to keep track of the time. The method update Raycaster takes as input the mouse or touch coordinates. It first transforms them from document to canvas coordinates. Then we call the setFromCamera method of the Raycaster, which computes the mouse ray in 3D. The start method first updates the Raycaster. Then we let 3JS perform a raycast into the scene. This function returns a list of intersections. If it is not empty, then the first entry is the intersected visual mesh closest to the camera. To get the physics object that owns this visual mesh, we use the user data variable of the mesh. If this is set, then we store the physics object. We also store the distance to this mesh. Then we compute the grab position as the origin of the ray plus the direction times the distance. Then we call the start grab method of the physics object with the grab position. We then set the previous position and reset the velocity. Finally, if the scene was paused, we start the simulation. In the move method, if a physics object is present, we update the Raycaster. This time we do not perform a raycast but only compute the new mouse ray. With its origin, direction and the grab distance from the down event, we can compute the new grab position. We also compute the velocity as the current position minus the previous position divided by the time that has passed since the last event. Now we can call the moveGrabbed method of the physics object with the new position and velocity. In the AND method, we simply call the ANDGrab method of the physics object with the previous grab position and the velocity. What is left now is to make the ball grabbable. First, we add a Boolean variable to know whether the ball needs to be simulated. In the constructor, we also set the user data variable of the visual mesh to the ball, as discussed before. All we need to add to the simulation function is to return if the object is grabbed. Now we have the 3 methods that the grabbable object needs to implement: start grab, move grabbed, and end grab. They're super simple here. We simply move the ball and the visual mesh to the grab position. In the end grab method, we set the velocity to make sure that the ball keeps moving when we let it go. In the next tutorial, we use the grabber to drag soft bodies. In that case, these methods are a little bit more interesting. This concludes this tutorial. In the description, I have a link to a page that contains all the HTML files of all the tutorials. I hope you had fun, and I see you in the next tutorial.